Vincent rubs a straw with an oven mitt and places it on the top of an orange juice jar. He is now able to move the straw without ever touching it. In this presentation, you will learn how neutral objects become charged, and in a future presentation, you will learn why Vincent's finger is attracted to the straw. Rub your shoes on a carpet and touch something metallic and you feel a shock. Pull a sweater over your head and your hair becomes frizzy. Remove clothes from a dryer and sometimes you'll find the clothes stick together. We've all had a direct experience with static electricity. The source of all electrical charge is found in the atom. Atoms are ordinarily neutral, which means the number of positive charges equal the number of negatives. There are three particles in the atom: the proton with a charge of +1, the electron with a charge of -1, and the neutron that has no charge at all. By the way, we actually get the terms positive and negative from Benjamin Franklin. Benjamin Franklin made many contributions to our understanding of static electricity. He proved that lightning was merely static electricity, invented the lightning rod, and built a static electricity generator. Benjamin Franklin even coined the term battery. Atoms become charged by gaining or losing electrons. Remember, protons and neutrons are never gained or lost when charges are transferred. In order to understand static electricity, you need to remember these three big rules. Opposite charges attract, like charges repel, and when charge is transferred, only electrons move. Only electrons are gained, and only electrons are lost. Atoms become charged electrically by losing or gaining electrons. When they do, they're called ions. When magnesium loses 2 electrons, it obtains a +2 charge. Fluorine tends to gain 1 electron and obtain a -1 charge. An atom with 20 protons and 18 electrons would have a charge of +2. So remember that when charge is transferred, only electrons, not protons and neutrons, are gained or lost. Protons and neutrons are actually held in the nucleus by an extremely strong force called the strong nuclear force. Ions, or any charged object, have an imbalance of charge. Negatively charged objects have more electrons than protons. Positively charged objects, or ions, have more protons than electrons. When the charged rod touches the electroscope, electrons are transferred and the leaves on the bottom separate. Any charged body can be made neutral by connecting the body to the ground. This is called grounding. When the finger touches the electroscope, charges either enter or leave the electroscope, and the balance between the negative and positive charges in the electroscope is restored. The bottom prong in some electrical plugs function as a ground. Should the device you are using malfunction, the excess charge will pass through the wire, through the ground, and into the ground. When grounded, negatively charged objects lose electrons and become neutral. When grounded, positively charged objects gain electrons to become neutral. In this presentation, you learned that most objects are neutral but can be electrically charged by gaining or losing electrons. Charged objects become neutral when grounded, and balance between the protons and the electrons is restored. Objects with more electrons than protons have a negative charge, and objects with more protons than electrons have a positive charge.